Hey, what's up everybody? Welcome back to another 3D Hangouts. My name is Noah West. I'm a designer here at Adafruit, and joining me every week is Spock Pedro.
What's going on, everybody? I'm Pedro West, Creative Tech here at Adafruit, and every week we come to share 3D printing projects featuring electronics from Adafruit.
That's right. This year we combine 3D printing and DIY electronics to make inspirational projects. Thank you guys so much for joining us. Let's go ahead and start the show with a coupon code. This is today's coupon code. It is FeatherWing. So if you're checking anything out in the Adafruit shop, you can use coupon code FeatherWing and get you 10% off everything in the Adafruit shop except for subscriptions and gift certificates. If you go to adafruit.com/free, you can see all the free deals that we got going on. So if you spend some more monies, you get some more free things. For $99 or more, you get a free half-size Proto, really nice. For orders that are $199 or more, you get free UPS ground shipping. And if you do more than that, $299 I believe, you get all that plus a Circuit Playground Express. So check out adafruit.com/free for all the deals. When it comes to shipping, same-day delivery is an option for the fine folks in New York City. So if you are in New York and you need your stuff like yesterday, check out the same-day delivery option. CircuitPython, our favorite programming language. We have a meeting that happens every Monday at 2 p.m. You can join in on that on our Discord server. It's going to be discord.gg/Adafruit. There's a little Discord logo thing. Newsletters, adafruitdaily.com. That's where you find daily newsletters, different categories. Check them out. New products, new news. This one's adafruit.com/newsletter. That's a good one. All right, well, that's the housekeeping stuff. Welcome everybody to the show. Thank you so much for joining us. We are live streaming. We do this show every Wednesday. Goodbye. And then we close the show and that's it. So yeah, what's up everybody? Thank you so much for joining us. We are streaming on all the networks. There's your coupon code. And shout out to everybody in the chat room. Happy Hallows Eve.
I was about to say Merry Christmas.
Yeah, Merry Christmas.
We've been doing Halloween for 2 months now.
It's 2 months.
I think we're setting up our Christmas tree right after
the show.
Because we got to do product shots.
It just makes sense. I mean, you got to get all the decorations out of here by the end of today, so you might as well throw it up in the attic and get your tree down. Mm-hmm. So that's our thing.
That's our efficiency workflow.
Yeah, that's our efficiency workflow. That's great.
Plus,
all right.
Who's going to be working on Christmas? Come on. Nobody ever thinks about that. All right, let's go ahead and jump into this week's
project. Let's go to the Learn Guide and see what's over there. All right, Paige, sing and dance. I got to fix this thing. We didn't have time to fix this thing.
You might have seen it on the web. We've been teasing it for about a month now.
Yes, there it is. Got
this super awesome saber.
Oh my gosh. This is our first lightsaber that we've ever built. Huge shout out to Lamar, Lady Ada. She designed a new product just to be able to build this thing. We call it, or she calls it, we all called it, the Prop Maker Wing. So the Prop Maker Wing is a brand new product. Y'all bought it. Thank you so much. We are sold out. We got to work really hard to make more. So the Prop Maker Wing is an add-on. It's a FeatherWing for our line of feather boards, microcontroller that has so many good things. You plug it into your computer and you can see your code. That's CircuitPython. That's amazing. You know how amazing that is. You drop the sound files right on there. You don't need an SD card or any of this stuff. It's already on there. There's built-in flash. You have the option to pick whatever feather you want. So if you want wireless connectivity, you want Bluetooth, get it. And then the Prop Maker Wing specifically has an onboard amp, right? Class D amp. This thing's nice. You got sound effects right off the bat. You get accelerometer using the LIS3DH. So that you can do lots of things like step detection, tap detection. Very cool. And then NeoPixel driver along with the 3-watt RGB LED driver. This thing's awesome. We're going to be using this for every single prop that we make moving forward. So if you go to the learning site, you can see that we have a learn guide for this specific prop. And the overview page will explain everything about it, everything you need. All the parts are here listed. There are quite a few of them, but you get the option to get what you want. Maybe you already have these components here, but take a moment to look at the list, see if you have it already. There are some things that you want to source from other places, like the polycarbonate tube, which we're going to cover, but for the majority of the stuff we carry in the shop, which is awesome. And I have it all listed here, as well as hardware supplies. Literally everything, every wire, every connector that you need to build this thing, it is listed here. What about the tools? What about wire cutters? What's that thing you use that holds the wires? That's all listed right there under tools. We use these for every single project, and they're really helpful to have. Prerequisite guides. This is going to set you up if you are completely new, you've never done any of this stuff before. This is going to help you out here. So we have specific guides for all of the products. So the mFeather Express, a welcome to CircuitPython, and even an excellent guide to soldering, which is always helpful if you're new to that. So there we go. All right, let's move on to the circuit diagram. So the circuit diagram is a nice little visual way to see how all the components are going to be wired. So this one is simplified, and it really just shows how all the pins, or how all the wires are wired to these individual pins. So that's just a visual reference. And then lower down here, we have all the actual connections broken out as with words, right? Yeah, so there are some options here. There's whether you want to have a really nice RGB button, for example, you can swap that out for a cheaper button if you don't want it to light up. If you want an on-off toggle switch, you can pick that, or you could pick a regular slide switch. All that's listed here. And powering it, so the way to power this guy is with this nice 4400 milliamp LiPo battery. It already comes wired with the JST connector, and it plugs directly into any of the Adafruit feathers. And you get onboard USB charging, which is really great. For the software, we were talking about CircuitPython. What's CircuitPython? This is a way to get Python on a microcontroller. Awesome. So we have a guide here that walks you through it. Most of our Adafruit boards ship with CircuitPython. That is awesome. If you have another type of Adafruit board, maybe you're using a Trinket or a Gemma M0, you can still use it. The wiring might change a little bit, but the libraries in CircuitPython will work as well. So these are the only CircuitPython libraries that are kind of required. So if you're stepping through it, and this is just a helpful way to know, okay, do I have the NeoPixel? Okay, I have the accelerometer library, and then bus device. So those are the three that you need to have. When it comes to sound effects, we give you a nice little note. We support 16-bit mono 22 Hz wave format, which is pretty standard. A lot of free open source software out there lets you convert MP3s and things to waves. You can make your own sounds, but we offer sound effects that are open source royal free. So that's nice because we're just kind of distributing them. So these are the sound effects that actually work with the lightsaber. We got power on, the idle humming, the swoosh, and a crash, and then the power off. So you have the option to change those out as you like. When it comes to the code, if you know a little bit of Python, awesome, then you already know how to read it. And if you're still learning Python, you can check out our guides that we have for micropython and CircuitPython, and also how to install Mu, which is a great Python editor for beginners. So this is the code. It's a nice embed. You can step through it. There's comments all over it as well, so it's a really good way to kind of digest and see how everything's working. Awesome. Moving on to the 3D printing. What a bad time for the mouse to die. So
let me get you some batteries.
Yeah.
Alrighty though, do a quick audio test. Looks like the positioning on my mic because of this Star Trek costume.
Your offensive shirt to us Star Wars fans. No, we just had it because it's a nice shirt. All right, cool. So moving on to the 3D printing part. Yeah, so this is I really wanted to make this thing work with multi-material printers setup. So you have a lot of different ways to do multi-material these days, and a lot of companies now offer, a lot of machines offer that as a kind of the standard thing, which is great. But if you have a single extruder, you're like, oh man, this won't work. It will. I have the parts merged and set up for you. So we're looking at hilt dimensions. This is going to fit on my printer. Yes, I think it'll fit on your printer. The minimum build volume that you need, that's required, 50 by 60 by 90. That's like every small printer, right, can do this.
Oh yeah.
I mean, it's a foot long, but it's because the parts they snap fit together and they screw together. So you can unscrew some of the parts and just print them individually, and then you just snap them all together, which is great. Yeah, so the whole assembly is documented here. Pedro's just kind of playing around with it a little bit. But if you go back over here, you'll see all the parts. There's 5 main parts that make this thing. The inner diameter is set there as well, because I know people might want to change out. Maybe they already have existing electronics, and they just want to print out a new hilt and maybe swap that out. So the inner diameter is 40 millimeters. Outer diameter is about 60 with the fins and all that sort of stuff. and it's about 1 foot long. So I thought it'd be helpful to have all the dimensions right there so you don't have to open any CAD files. Speaking of the CAD files, they are up on all the social sites, so you can check them out. Source files are there. That means step files. That means Fusion 360 files. They're all there, not just STLs.
If you're going to be modifying, do not grab the STL files, please. We saw somebody post this up in one of the Discord channels.
Yeah. Yeah, don't import STLs.
We do a lot of work to make sure that these Fusion files are all nice and editable, and when you import an STL, it just breaks our heart.
Yeah. All right, well, when it comes to which part's which, we break out every single part. So the dual extrusion parts are all here labeled. Single extrusion parts are here as well, and then all the additional stuff. So the stuff that are outside of the hilt are things like the mounting brackets for the actual PCBs and the blade cap. If you have a blade that's, if you have a polycarbonate tube and you need a tip, I made a tip for 1 inch outer diameter polycarbonate tubes, which is nice. Definitely recommend using translucent PLA for that tip for your blade. Parts assembly, so I made a little CAD animation that kind of shows how the parts all fit together. We can play that now. So you want to start with the kind of barrel and fit the PCBs inside there. This little clamp kind of has a split in the middle, so you can pull it apart and then put those 2 pieces together, and then there are threads on the pommel and the blade emitter. The blade itself is press fitted into the blade emitter. Awesome. That's why I made that CAD animation. We'll have to sit there and kind of play with it. Cool. When it comes to slice settings, we 3D printed this on an Ultimaker 3 using the latest version of Cura. I've just put 3X. I also have some 3FM. I don't know what their file format is. It's like 3FM, something like that. It's you basically load it into Cura. All the slices and all the STLs are already positioned and set for you with all the support material if you need it or not.
Packaged file of settings and the STL. So you can
this is the first project where we kind of released those because we never had to.
It's a really good idea to doing it
that
way,
is,
because then if you want to use a different nozzle size or different material, all you have to do is change the settings for those.
Yeah, you can do that too. But yeah, because it's a dual extrude file, I wanted to make sure that those were available too. Cool. All right, and then, so what filament do you use? People are starting to ask us what filament do we use, so I'm starting to add this to the guides. Glitter-infused filament from Filamentum. Okay, Filamentum is this guy over here.
Not just that it's glitter-infused, it's the high quality from it. Some of the other materials that we tried, the smaller fins came out a little bit more extruded, not as high as quality as the
This is premium filament from Filamentum. It's PLA. They call it the extra fill line of filaments. So specifically, the colors that we're using here is Vertigo Galaxy, Rapunzel Silver, Vertigo Gray. Those are the 3 colors that we're using here.
There was an attempt to do the holder for the saber or for the wing in a translucent blue material, because somebody's asking. All it's missing is the crystals on the inside, and you did attempt that.
Yeah, I
have
did.
A holder to be that translucent color for the crystal.
Yeah, the little mounting brackets. Yeah.
So you could definitely do that.
Yeah, the crystal's on the M4, a real crystal, like an oscillating crystal. You know what I mean? Yeah, there's a crystal in there, guys. Come on. Also the LEDs
and
are.
a quick question: if you don't need all 3 off and on buttons, no, you don't need them all.
No, one of the buttons is an extra button to be sort of a cycle, so if you wanted to do colors. So this is kind of future-proof, where I want 2 different buttons. And then you have the option to use a momentary button or a latching button if you want it to be the on and off switch. But this thing uses sleep mode, so it's when you power it off, it's not using much. Yeah, so there's where the buttons are. Cool.
You can even fit a 3rd one in here if you want to get rid of the grill detail.
You could fit many things. Potentiometer, maybe you want to adjust things on there. Yeah. That'd be really cool. Adjust, cool. Yeah. Or maybe cap touch buttons. There's a lot of options to do here. Yeah.
Just have this be the cap touch.
That'd be cool. Yeah. Super hidden. So dry fitting the parts is definitely important when you print them out. You want to make sure that all the coils and tolerances fit pretty well. I do offer the recommended slice settings here. Mainly the line width is what I like to kind of change and make it a little bit thicker than it needs to be, because it kind of makes the part a little bit better. But you have the option to do it too. Yep, and if you don't have a 3D printer, 3D printing services like Make XYZ, 3D Hubs, or even the Adafruit Jobs board, you can use them, or check out your local library. I think local libraries these days have 3D printers, and of course your local makerspaces or schools, because we've donated a few. Sweet. So let's take a look at the FeatherWing. So the way to get a feather wing on top of your feather, there's so many different ways to orient the boards. So the way I like to orient them in this project, I have it documented here. So we want to use the short headers, the short female and male headers. So we have those up there. They're the 12 pin and the 16 pin ones. I have a little trick here on how I like to solder my headers. I use a breadboard where I will snap in the headers and then I lay the PCB on top. That way it's kind of held in place for me already by being press fitted into the breadboard. Installing the female headers is a little bit tricky because there's not a good way to hold it. So what I like to do is once I have the male header pins soldered to the actual feather wing, then I can kind of install the female headers onto those pins and then use a pan of ice to hold the assembly together so that the gravity is just holding it down. And then you can solder it in place and get this nice little feather wing assembly. Excellent. Talking about the buttons, now we carry wires, pre-made wires, JST cables, 2-pin, 3-pin, and even 4-pin. But they use PVC insulation. Yeah, covers?
The coating.
The coating, yeah. They tend to melt instantly. You just look at it and you can melt it with your body heat. So I am a big fan of making my own with the silicone stranded wires. This wire is really nice. It comes, we have them in stock, surprisingly. We have quite a few of them, different gauge. Well, they're all 28 gauge. There's a 30 gauge one, but I like the 4-wire because it's already ribboned for you. They're already attached, so you get this cable as opposed to like a whole bunch of spaghetti wires. So using this is really nice. There's also a little marking on it to let you know if that's power or ground or whatever you want it to be. So it's really nice. You peel it apart like cheese, like string cheese, and it's a really nice wire, really high quality wires. It's flexible, and that's the main idea. If you're going to take this thing apart a bunch, definitely check out silicone cover stranded core ribbon cable. Nice name. So I have those listed here. I also recommend getting a JST PH connector kit. I got this one from Amazon. It has like 700 pieces. It's got all the little pieces and stuff. You can crimp them yourself if you'd like, and man, they're just awesome. So it's a 2, 3, and 4 pin kit, and I think we're going to try to stock that. Don't quote me though. Very cool. So here's what all the buttons look like. We are using these JST connectors because, well, it's just
there's a lot of connections.
There's a lot of connections to make, and everything's embedded and panel mounted, so you want to be able to disconnect things. So the best way to do that is with a connector that's small. And the JST PH cables are just the right size, we think. There are many, many types of JST connector types. This is the one we like, the PH one. Okay. I solder directly onto the pins of the buttons. And the one tip that I have is to solder them at a right angle so that you have less wires kind of sticking out inside of the clamp. So that's my little tip there when you're wiring to this. And if you want to use those quick disconnect things, don't use them because then you're increasing the length of the profile, and that might not fit within the 40 millimeter diameter. So that's why I recommend doing that.
Number one thing that's overlooked when you're designing a case is wiring.
Yeah,
So
ample space. Yeah, ample space in your thing.
a bunch of room.
Yeah, so this is what it looks like with the 2 buttons wired, and they have those connector bits in the middle, and then we want to attach the male connectors to the prop maker wing itself. So that's what we're wiring into. Really, really nice silk screen. It has all the labels for you. You don't have to like look and see. They're just labeled as they are. You got the switch, you got ground, you have a power pin, NeoPixel pins, and the RGBW pins. What's cool about the RGB driver is that we can go up to 3 watts, or you can do regular LEDs, which is what we're doing in the RGB button. They're just regular LEDs. There's already resistors on it, on board, so you don't have to worry about wiring a resistor into your LEDs. We got that covered for you. Sweet, and then the extra button is going into any of the digital pins, and this one I'm using the pin number 5 on the feather, which is also the IRQ pin. And then you also have the option to solder it to the enable pin if you want to completely shut the power off. So those are your options. And that's what it looks like with the feather wired up. There are wiring strain relief holes which you can use. which is always nice. But I kind of like using it this way, so you have those available if you'd like. Cool. As for the speaker, these speakers are available on Amazon. We're trying to get them in stock, but for now, you can hopefully next week. Yeah, these are really nice. These are 3-watt, 4-ohm speakers. They are like little mini baby subs. They can pump out some sound.
Are so loud.
Yeah. Do you guys want to do a demo real quick with sounds? Let's check out the sound. So, what I like to do is I'd like to show the volume and see how loud we can get it, how quiet we can get it. So it's already on. I'm going to turn it on. So you get that on effect. I'm using this little screwdriver because there is a trim pot right where the amplifier is. So if you wanted to tune this up, if you're at a con that's really loud, and you wanted to tune it up, it's very loud. Why did you wear that shirt? So anyway, you can turn it up, turn it down, which is what I'm going to do. I just killed everyone's ears to make a point. I'm so sorry about that. But anyway, if you want to, so if you want to adjust the volume, it's a pretty loud speaker and a Class D amplifier, which is super nice. Did everybody leave? Sorry. So interesting thing about the speaker, we're starting to use this Molex Pico blade connector, which is like a nano-sized version of the JST-PH connectors that we were talking about. So on board the prop maker wing itself is a Pico blade connector. So that's why we're starting to store these. That's why we're starting to store these cables. So pick up one of these cables, and then you can just plug the speaker directly into the feather, the FeatherWing.
So nice.
Yeah, it's pretty nice. I like it. Yeah. All right. Cool. So the next thing, once all those components are soldered and wired, it's mainly just those 3 or 4. You can start plugging things in and testing stuff out. So this is where you want to test out your buttons and your speaker. The next one, we're going to talk about the blade construction. Now the blade construction, I got these blades from Ultra Sabers and the Custom Saber shop. So I got 2 different ones, and to actually light up the thing, we are using the mini skinny Adafruit NeoPixels. So if we take a look at these mini skinny pixels, these are using are they 25-25, I believe, or 35-35 sized LEDs. These are very, very tiny LEDs. And the interesting thing about this is that your standard 50-50 sized NeoPixel strips, they're wide, and when you try to fit it inside the blade, you kind of need 2 strips to illuminate the back and forth. That's expensive, and that takes a lot of power. So what we're able to do is use one mini skinny strip, the high density ones, and just use that instead of having to double up on them. And that was able to illuminate the polycarbonate tube. Speaking of the polycarbonate tube, Ultra Sabers is a great supplier of these super nice, heavy grade polycarbonate tubes. So these tubes are not just bare tubes, they actually have a resin cast tip for diffusing the tip. It's rounded, or you could choose a pointy tip, and it's thick. It is a thick.
It is really thick, yeah.
It's like you can hurt someone. You need to be careful with this blade. But
if you're getting attacked, you take solace in knowing that you could you could crack their skull open with this.
Do some damage on it.
Yeah.
So these are high-grade polycarbonate tubes. They're about 3 millimeters thick, and they come with a light diffuser material that's already like pre-fitted inside, so you don't have to worry about using parchment paper.
Amazing the way that this is diffused.
Yeah.
One strip, we were trying to stick 2 strips together to make a double-sided LED strip, which was obviously gonna double the price of the strip, the bomb for this.
Yeah.
This dramatically reduces the price in terms of that.
Gives you better battery life, which is awesome.
Yeah.
So they're about like $5 more, but it's definitely worth it because you're saving on having to double up on them.
We tried getting both sizes, the 32 sized ones? And
so we made so there are different size blades. There's 24, there's 32, there's 40 inch. Yeah. We really like the heavy grade. One. Yeah, I like the shorter one because you can just not worry about kind of hitting everything in close quarters. So if you're like at a con and you want to swing it around, you don't want a giant blade, but you can swap it out. Look, this is maybe you do want one.
You can swap it out.
Yeah.
You can switch between those.
Yeah, so this is really cool because we're using a 3-pin JST connector, and you can just plug it directly into the FeatherWing. So you can just pop it out and swap out your blades if you want, which is really nice. So you want a longer blade, you can swap it out. But ideally, when you're transporting, when you're on a plane, you don't want it to be that long. You want it to be a little bit shorter, so you can just unscrew the blade and put it in one of those like
disassemble the entire
gator
thing.
bags. Yeah, disable the whole thing. Cool. So back over to the guide. So we can take a look at our stuff here. So the one thing you want to do though is, although you could just stuff the strip in there, it's floppy, right? It's made out of a flexible PCB. So what we do is we have some corrugated sheets of plastic. Sometimes it's called Coroplast, and every art store kind of sells this stuff. So we're using the 4mm thick stuff. You can get about a 20 to 30 inch semi-translucent sheet with 4mm wide corrugations. Then you can just use a box cutter to cut them down to the size of the inner diameter, which for me was about 12 millimeters wide, I believe. Yes. And then what you can do is you can use some double-sided tape, like Nitto tape. I really like using Nitto tape to secure the flexible LED strip to the actual plastic core, the plastic strips that we made out of the Coroplast. Yeah. Now these LED strips do come with pre-soldered wires, but we are going to replace those and get rid of the weather sheathing. It comes with the weather sheathing, and it's kind of hot glued, so you do have to use a box cutter to kind of strip it away, and then you can just pull it out of the weathering, which is what we have here. If you ever want to increase one of our photos, just click on it, and it'll open it in another tab here, and then you can see it really big here. You can see here that the LED strip is outside of the sheathing here.
Definitely saving that for future.
Yeah, you can save it too. All right, and then
good tip from TrueTech on the Coroplast. You can use recycled election signs.
That's brilliant. Yes, because that is what the election signs are all using. This Coroplast stuff. Cool. That's a good tip. All right, and then kind of desoldering the pre-soldered wires for some thinner wires and ones that actually have the 3-pin JST connector. Because we carry these now, these 3-pin JST connectors is what we're using here. Or you can crimp your own using the silicone wires, which I actually would recommend. So that's cool. And then strain relief, it's just kind of adding some heat shrink tubing and that sort of stuff. Adding a dab of hot glue onto the solder pads is really helpful. That way, if you twist the connectins a bunch, it won't crack the PCB because you'll have that hot glue as a strain relief, which is nice. Definitely want to test out the NeoPixel strip before we start stuffing everything. And then at this point, you can actually start to measure and gauge how many pixels does your blade actually need. I have two here. I have a 24-inch. All you need is 85 pixels. You have 144 to work with a high dense strip. And then the 32-inch only uses 114. So you have like this extra strip that you get to cut off, and you can cut these, which is great. These are high density, but because the pixels themselves are 35 size, you get those
There's
pads. Yeah, so you can cut the strip and solder in between them if you'd like, which is kind of neat.
Which you can't always do, unfortunately, with the high density ones, since they're so close together, you don't get any pads.
Yeah, but this one you get the pads, which is great. Yeah. So the next thing you want to do is you want to start. So once you've measured out your strip, you definitely want to start truing up your Coroplast backing. So what we do is you get two of them, you make two of them, and then you sandwich it in. Talking about the Nitto tape, I really like this tape. I have it linked in the overview, but this is really nice double-sided tape. It's about an inch, about 25 millimeters wide, so it fits perfectly on the strip. And it's some sticky stuff. I mean, I use Nitto tape to secure aluminum to my other mill, or Bantam tools, to do machining. So you can use this stuff for machining. It's really nice. Tough. Nitto tape. Check it out. Yeah, peel and stick. That's what I have here. And then I just use regular Scotch tape, clear tape, to just wrap it around to kind of sandwich the LED strip into the two sticks of Coroplast. Here's what it's kind of hard to film this, so here's what it looks like. It does diffuse the light a little bit, but mostly it's just to kind of be a backing for the LED strip so it's not so floppy. but it does give it a little bit of illumination, a little bit of diffusion as well. And then installing it into the polycarbonate tube, you want to make sure that it's not too wide, it's not too thin, because then it might kind of jostle around inside the polycarbonate tube. So you kind of have to do your own measurements and things like that. But if you are picking the same ones, using the 10 millimeter wide version works really well. The Coroplast making it 10 millimeters wide. Yeah. Plugging up the tube, I just used, again, Scotch tape to keep the stick, the LED strip, from falling out of the tube. So you can do that. Or you can use hot glue if you'd like. I think hot glue would be safe because you could just peel it if you want. And then press fitting the blade into the emitter. You definitely want to try this. You want to dry fit this. It gets press fitted pretty nice. Yeah, it's
really tight.
Yeah, but be careful because once it's in there, it might be kind of hard to get it out. Yeah. So
it requires a ton of force to get it out. You can.
You can, but yeah.
Obviously, it's that way, so you can swing this as hard as you can.
And the blade won't just come flying out. Yeah, so that's really nice. And then testing it out. So test it out. You get evenly diffused top and bottoms, which is really nice. And here's where you can experiment. So if you want to use something else like dot stars, you want to do like a precision vision type project, you can use dot stars and other strips and stuff. Yeah, so that's really cool. So that's the blade construction. I think it was the most interesting part of the project because it's just getting perfect even light distribution is kind of a challenge. Talking about the board assembly, the two PCBs, the Adafruit Feather M4 and the Prop Maker Wing, those are attached to two separate little circular mounts, which are these guys here. And then we have some hardware here. So we have some M25 screws and some heat inserts, or threaded inserts rather. And we just kind of walk through how these guys are secured. So the feather is going to get secured to this bracket here, and then you have some of these threaded inserts that kind of act as nuts to keep that secured so they don't get loose. And then securing the feather is pretty much the same, but on the opposite bracket. So one of the things about the orientation when it's inside the hilt is accessing the micro USB port on the feather. So we broke it out with a micro USB breakout board. These are really handy if you're embedding your part all the way over there and you want to access programming and recharging all the way over here, you might want to use and consider using a breakout, a micro USB breakout. So I took a USB cable, cut it in half, made sure it was the data cable, and then just soldered it straight into the pins. And it's got this nice little kind of short, custom-made micro USB breakout. It's kind of neat. So I just kind of walk through installing it. I just plug it in, and then it gets mounted to the side here. I can click on that photo so you get a good look at the way that is. Go original, and you can see that's the micro USB gets secured there with those two screws. Very nice. Okay, let's go on to the final assembly. So there's a lot of GIFs here because you kind of need to kind of see it in motion, but I also have it written out there as well. So installing the buttons, you want to do it with the JST connectors first. They're just panel mounted. These buttons come with the hex nut, so you just kind of use that to secure it. There's like special geometry in the clamp so that the button is flush with the surface of the kind of raised embossed thing going on there. Got a second button. For the second button, I just went with a regular red 16 mil panel mount button. Doesn't do anything special, it just kind of sits there. As for the speaker is just press fitted into the bottom of the pommel. Like that, it just gets held in there. And then the 4400 milliamp LiPo battery goes inside of the power cell part. It just gets snap fitted in there. It has these two little slits so that you can thread the cable from the speaker through, which is nice. There's ample clearance there so that you can just insert it in, and the JST connector will just kind of pop through it. Here's what it looks like there. Now you want to connect the pommel to the actual battery holder. Just screw it in. Just screw it tightly. Obviously, you want to press fit it before doing this. Make sure it all fits. And then to install the PCB mount assembly into the barrel, you just kind of fit it in there with the cables going head first, I guess we could say. And then the barrel barrel USB. Yeah, just getting all the wires to come out of that hole there, just fitting that stuff, kind of finessing it a little bit, make sure none of the wires get kinked. Then you want to install the clamp onto the battery holder, or the power cell, that's what I like to call. Because of the clamp design, you can use your finger to kind of pull it apart, so you can just kind of press fit it in there. And then to lock it into the power cell, there are these little indentations, and there's a little kind of a notch that will get mate, and they kind of twist and lock into those little grooves. So it's kind of this way to keep the pieces from just sliding all over the place. So it's got like a register key on there, which is nice. And then getting all the cables, connecting them all to the the JST connectors on the PCB assembly. So just connecting all those things, depending on what buttons you used or how many you used. That's where you can start connecting everything together. Pico blade, connect the Pico. That's from the speaker, so you have access to that. You have the ability to kind of rotate and adjust the PCB mount because it's kind of freeform in there. So you can set it to one side and then plug in the Pico connector. So you have access to most of the connectors there with that sort of opening for the barrel. And then getting the clamps to the barrel, same kind of dealie. Just use your fingers to pull apart the clamp and then just fit it in there and get the thing to lock in there by twisting it. Then the last thing you want to do is connect the battery to the feather. So again, just kind of rotate, plug it in. It'll turn on as soon as you activate the button. And then the last thing, the clamp, to keep the clamp from coming loose, we're using this 16 millimeter long M3 screw and lock nut. It's the nylon lock nut. And then just screw that until it's nice and tight. And then because it's a lock nut, it won't unfasten itself, which is really nice. Connecting the NeoPixel, just plug in the 3-pin JST connector to the board. This is one of my favorite features of the Prop Maker Wing. Just plug in a strip. Yay. And I could unplug it as well, which is awesome. Then you can, if you have any excess wire, just kind of, there's plenty of room in the hilt to kind of coil that, wrap it around, make it nice and neat. Use heat shrink where you can, that sort of stuff. Yeah, and then just kind of screw the emitter on. Give it a turn on and see if it works. Sweet. Yay. I got some maintenance. I got a page for maintenance, like one note. So the USB battery, right? Charging USB. Feathers are meant for small things, for small batteries. Things that are like 500 milliamps and under. It's great for those batteries. But what about a 4,400 milliamp battery? How do you recharge that? Well, the milliamp charging rate on any charger is always going to be different, right? So the one that's on board, the Feather, is 100 milliamps. Want to do some math? 44 hours to fully charge the battery. That's a little bit, that takes a little bit. So we carry this guy here. This is a micro LiPo charger, and I recommend using that because then you can, it has a charging rate of 500 milliamps. That's like a half of an amp, and that takes 8 hours to fully charge. This is a big battery. This is a 4,400 milliamp battery. It's pretty nice. Your iPhone doesn't even have that.
Yeah, I don't think we mentioned that this is pretty heavy.
It is 2 pounds. It weighs 2 pounds. That's why the kid is holding it with 2 hands, because otherwise he can't hold it.
5-year-old. This is pretty long and heavy.
Yeah, for him. Yeah, but he still managed to swing it around pretty nice. He put up a good fight. So anyway, I have that there, and if you already have one of these, great, use it. If not, you know about it a little bit more now. So that's cool. Reprogramming, so to reprogram it or add new sound effects or anything like that, you can.
Or some lighting animations, as people are asking.
Ooh.
If there's any more, definitely a, what do they say, a mini force lightning would be cool to add.
Yeah.
We're going to be working on more animations for more propped projects for this board, so be on the lookout for that. But for now, yeah, it's just the turning on and turning off animation, and of course the strike animation.
So it does strike.
It's just 3.
Fun note, and if you look at the code, you have 2 thresholds. You have a threshold for the swing, and we didn't even play the swing, and a threshold for the swing. So as it's idle, see that? And then crash. So you have 2 thresholds, the crash threshold and the swing threshold. So you can adjust those numbers if you want to fine-tune how much, I guess, force you're applying to it. No pun intended.
It's called Schwartz.
Schwartz. Don't touch the blade. Ah. Very nice. Here's the tip.
We want to compare to an official lightsaber. We picked this up at Hollywood Studios over at the Star Wars launch bay after we rode one of those rides there, the little simulation there.
Yeah, the Jedi Academy.
Yeah, we're at the Jedi Academy.
Yeah,
there.
this is about, this is 30 or 40?
This was 20
bucks.
But this is with our annual pass holder discount.
Yeah, so it's like 30 bucks. Yeah, so it's a cheap thing, but it's kind of nice.
It was pretty nice,
yeah.
Except when we decided to take it up against polycarbonate and broke the
almost shattered it in half.
But if you're using 2 of these to battle each other, you should be good.
It's pretty nice, yeah. Go ahead and turn it on. Let's hear it. So it's got some nice sound effects. Now, of course, their sound effects are better because, I don't know, they have Disney and Lucas license.
Sound engineers that
created
these.
Yeah, we had to distribute the royalty-free stuff. They might not be the best, but they're really nice.
In terms of the build, you can kind of see some of the inspirations that was taken from one of the official toys from them.
Yep.
And I think ours looks better.
You think ours looks better? Yay.
Yeah, well, we're able to do a lot more.
This is neat, though. I really like what Disney did with this one because you have the option to kind of build your own hilt. So you take this stuff off, and it's kind of like a skin.
You
take it off. I had to build it, yeah. And then this is the naked hilt. I took it apart and looked at all the stuff, and it kind of follows the same. It's got a little speaker in here as well on the bottom of the pommel. Man, this thing is super light. And the batteries, I believe, are just like 3 AA's or something. And then you can take this off. The way they did their lights is just arrangement of regular LEDs. They're not even like powerful LEDs, it's just like regular LEDs. It's basically a flashlight, yeah. And one of the really cool things I like about it, there's no motion sensor. This is all just a tilt ball switch. But they have something neat here that maybe we can try to do something like this. So there's this little hidden trigger button here, and if you hold it down, it actually dims this down. Gives you some nice sound effects. So, if I were doing this project and not sharing it to the world, I might, record those and maybe make a wave out of them and put them in my project. But I can't distribute that.
You can add more audio. Yes.
You can, yeah. Yeah, we have tutorials on what?
The ability of CircuitPython to load as a USB thumb drive. So when you plug this into your computer, it loads as a USB thumb drive.
That's right.
And all you do is drag and drop your sounds in.
Yeah.
And that's it.
Yeah, and I told you guys what the right mono and whatever bit rate, it's listed there. So you do have to convert it, but there are a lot of online converters like Audacity. That's a good one to get your file in the right format, in the right kilobit. But that's details and stuff. But yeah, absolutely possible.
As Adam was saying, something like
Okay.
Mega Man or Mario.
Oh, that's a good.
Pretty
Yeah,
cool.
that would be really cool.
Yeah. Just find files, drop them in.
Yeah.
It's already looking for those, for any files. Actually.
Yeah, even funny things. I really like how Bob Claggett did his from I Like to Make Stuff. When you turn it on, you hear Yoda go. That's great.
Tons of
So you do little Easter eggs.
very easy ways to change the audio effects on it.
Absolutely.
Drag and drop them in there.
Yeah. I mean, you could take this circuit and build something completely different. Make a blaster, make one of Han Solo's blasters or something. Very cool. Back over to the guide. I think we're done. Yeah, we're pretty much done. That's the maintenance page. That's the last page. Again, all the files, all the source things are open, so feel free to remix them. Just tell people Adafruit, and then we're good. Yeah, so there you go.
Show off is a battle. Where's the other one?
It's charging.
Yeah.
Yeah, I'll let it charge. Yay. Any questions?
Let's see. Solid state battery. Cool. Yeah. Once we can check some out that we can actually buy, stuff that's going to be on the list.
Mm-hmm. Now there are some really cool ideas out there. Wireless charging, Bluetooth connectivity. All these things are stuff that I think we'll have to work on as we get to it. Right now, there's a lot of development being done right now for the NR52 chipset. Mm-hmm. And we'll hopefully have Bluetooth APIs and stuff with CircuitPython. That'll be super rad. That's coming. It's being worked on right now. It's been being worked on for many, many months, which is great.
AT Maker's Bill Binko
Hi, Bill.
is saying which feather? Yes, the M4.
The M4
feather for all the audio effects, fast processing.
M0 also will work fine. Mm-hmm. I just like the M4 because it's like future-proof in a way.
Mm-hmm. So definitely check that out. Mules Adam is saying, yeah, he wants to think up of a cool handle type. Yes, totally. So the original handle that Noah was going to actually use was the Obi-Wan.
Yeah, this is a design from Valcro. He posted it on everywhere on Umagine and Thingiverse. He made this to be fully 3D printed and kind of snap fits as well. So I printed this out. It's an open design as well. And I was just like, wow, this is really great. So I kind of studied it. And I actually, the first version I did use this kind of feature. But I kind of, what do you call it? When you ditched it? I guess I ditched it because after playing with it, I started getting blisters on my hands.
Yeah, so there's another thing you want to think about too when you're designing your own.
Ergonomics was something I thought about at the end.
Super cool, but how does it feel in your hand?
Awful. Like it was awful.
Yeah. I mean, yeah, that's...
Blisters on my hands, really? From that, yeah.
I got blisters on mine from doing the blade assembly.
Yeah, that's right.
Thomas is saying, yeah, Bluetooth to vibrator, so you can make it look like Luke's in the snow.
Yeah. You need to link to Azure Skies' build, which he's still working on, but he shared it on I want to say maybe a month ago on the show and tell, and boy, that thing is amazing. Yeah. He's got a hidden button, so it looks like he's got the Force in his gloves, so that's really, really nice, really, really clever way to do it. Also, the way he's doing his blade is it uses pogo pins, so you kind of snap it in. Really, really smart stuff. Custom PCB for that. Very cool stuff. You can see all that in the Discord channel as well.
Yeah, he's actually in there right now. He said he is at work.
Yeah.
Check out the replay.
Sweet. Alrighty.
But definitely ask Azure Skies for any other
advanced huge shout out to Azure Skies. Because of Azure, I was able to source a really high quality polycarbonate tube. Because what we were using before was those bulb guards, which is a great prototype thing, but you cannot use that to battle, because I did, and it had all these marks and kinks. It's super thin. Polycarbonate is strong, but it depends on how thick it is.
And as I was saying a couple of weeks before, the blade really made the difference.
Yes.
The whole time we were working on this, we were like, yeah, it's a lightsaber, whatever.
Right.
Then when these came in, we actually started battling with them. We were
like, oh my god,
wow,
this dramatically increases the quality of the builds.
Which obviously boosts our,
our excitement,
the passion to actually complete the project and do really good job on, just the tiny little nuances of design things for it.
Yes, I have dropped it many times in 5 different ways in 5 different places, and it just kept breaking. I just kept making it thicker, getting those stress points a lot thicker, and upping the infill count helps a lot too.
Yeah. Another really good comment from TrueTech is saying maybe use the bike hand grip coating or Plasti Dip.
Oh, that's great.
The handle, sort of have a nice little feel on there.
Or we should use NinjaFlex.
Coating, and then you could just use any filament that would work, because you can just
that's an interesting one.
Coat it. And then Bill Binko is asking, where do we get Filamentum? We just got it off of Amazon.
Just search for Filamentum. I linked to their site.
Yeah. They had a sale the other day.
Yeah.
Is it still going? What was it?
I don't know.
50% off or something?
Maybe.
Check it out. We have the colors that we used there linked.
Yes.
The Vertigo,
Galaxy, Gray, and Rapunzel Silver.
Yes.
Yeah. And they come in both size diameters, so they're good. And it's high quality stuff, so very nice.
Oh, that's a good idea. Yeah, Thomas is saying have the impact threshold not only change the sound, but make it vibrate a little bit.
Wow.
Pretty cool.
Yeah, we could have a vibrate thing in there.
And then somebody was asking about using vape effects for smoke.
Oh,
you
gosh,
could probably add a different chamber down in the hilt here somewhere, maybe like in between the speaker and
that would be
the
cool to
speaker
have
and
it
this
come from
right
here, the blade emitter.
Well,
I think that.
Never mind. Yeah, up here. What I was saying down here.
Yeah.
Somewhere up here, maybe to have like the heated wire, some sort of way to heat up the vape juice so it'll emit the smoke upwards. That is definitely on the list. On figure out a way. We did look at some Kenthal wire to stock in the store for heating elements. So there's a bunch of stuff being worked on in the background.
Yeah, very cool. Yeah,
there's too much stuff being worked on in the background.
Yep.
So Kirby is saying yes, Matter Hackers. We actually got a ton of it from Matter Hackers as well.
First,
we were getting it from everywhere we could pull, because people would run out of stock and be like, "No,
I ordered like 4 crates of it. And shout out to Filamentum.
They sent us.
We reached out or something, and they sent us some too. Yeah. After I've spent I don't know, $1,000. That's a lot. A lot of filament. Okay, sweet, great comments, guys. Keep them coming. Yeah, and if you have more comments and stuff, you can always hit us up on the Discord channel, which is where we're hanging out right now. So check it out. We're in the live broadcast.
Speaking of broadcast and chat rooms, Bill's also asking, how is Restream.io working? That's all we use.
Restream is great because it doesn't bog your system and your bandwidth. You're just streaming to one place, and then Restream is streaming it out and doing all the hard work for you. You do need to do a little special custom RTMP for Facebook because they don't want you to do what we're doing. Don't tell them that. But it works really well.
I'm pretty sure
we're paying for this, right? We're paying for
Restream. It is a pay.
Yeah, so if you're serious about streaming, consider supporting that service. It's a good service. Sweet.
Well, jumping into this week's
what do we forget?
Actually, prototyping or just shop talk stuff?
Yeah, so go straight into shop talk / prototyping.
I wanted to give a shout out to one of the ways when we get a chance to talk about the production of how we do our videos and stuff. It's always helpful when it has to do with cool little 3D printing help from the community here. So DJI Osmo Mobile, we needed some gimbal hardware for recording a lot of the lightsaber fights that you saw.
This is version 1.
Version 1, not the version 2. The only drawback is that you need a counterweight on one of the sides because we have to use a wide angle lens because of the just how long the saber wing is, or the saber blade is. So we need to be able to capture as much as we can while still being close to the action.
Yeah.
So we're using the Moment lens, which is super high quality metal and glass. This is this is the best.
It's a premium lens for mobile phones.
Yeah. Using the iPhone XS because it is freaking amazing in terms of the low light quality that you're able to get under there. If you guys saw the video, those nighttime shots.
Yeah.
What?
Yeah, it's pretty good. Yeah. We're looking to invest into a new camera, and it's like it's in your pocket.
This is 4K.
It's pretty nice.
This is 1.4 f-stop.
Yeah. So anyway, the lens is so heavy that you need a counterbalance for something like the Osmo, which is a stabilized unit that is meant for mobile phones. It works with Android. It works with your iPhone. Probably even works with the Red phone, the Red Dragon phone. Whatever.
The only problem is that the counterweight you're going to need because of all of the weight's going to be on one side.
1 pound of glass.
They do have, DJI does have a little adjustable arm on there that you can compensate for that, but they didn't anticipate this heavy lens being on there, so when you try to turn it on, it's just not going to work. Luckily, somebody on Thingiverse came up with a really good way of adding a counterweight to the other side. This isn't it here. I modified it. If you go over to the
Thingiverse page?
Thingiverse page.
Yeah, so this is it. Yeah, and the Moment company, the guys that run the Moment product, they also made their own kind of counterweight thing.
It's not even available yet. I was going to buy that.
They show you how to DIY your own.
They do show you
They don't 3D print it, but it's still like, hey, here's how to do it. Yeah, here's how to do it. Yeah. So this gentleman here, JTKD, kind of started this is just great about open source. He's like, hey, here's it is. You asked for the Fusion.
I didn't know, I didn't have an idea of how to actually do this, and I wasn't going to because, we were crunched on time. So I quickly searched, found a couple, and this one was the best way in terms of the implementation of it.
Yeah, just 2 parts.
Print it out. And
put some washers.
It was just, this is for the Osmo Mobile 2.
Yeah.
We have 1, looked at reviews, kind of the conclusion isn't really worth getting the 2 since there's, you're still going to need a counterweight for it anyway. Oops. So tried out his model. There it is. Good job on it.
It doesn't even look 3D printed for you because you printed it in the glitter, the filament. Yeah.
So yeah, he sent over the Fusion 360 files.
And you asked for it, and you shall receive.
Super.
Shout out to you, sir.
Clean timeline in the way that
you
model it. So I was able to go in there and modify the. Did have to redraw some of the sketches just because the shape of the arm is a little bit different.
Oh, okay.
He was using hardware nuts to secure this in there. I went in, just added threads, 3D printed threads to hold in these, forget what it is, 5/8 size washers that are acting as a counterweight for that.
Right.
And just
so the cool thing about this is it's you're able to fine tune the weight because each lens is going to be slightly different, and you can just add or more.
Yep, we have fisheyes, we have telephotos, and of course the 18mm wide-angle lens right here.
Should I load up the Moment site just to like give them a shout out?
This works with any phone, so if you're really, it isn't really, we're looking at, getting like $10,000 cameras for a lot of the video production where we have like, $100,000 worth of lenses and all that. We used to be in agencies. We have all this equipment.
Yeah, I think if you're starting out and
this
you're doing
is definitely
videos,
the way to go.
Use your mobile. Get a nice lens. They just got an anamorphic lens. They got a lot of accessories and things, but they got premium glass, which I really like. So
yeah,
not just iPhone, Pixel 3, and all that good stuff. So there you go. There's the Moment.
Almost
lens
all
company.
modern phones.
Oh, I almost forgot to mention the way the lens attaches to your phone is with this really clever case that has like this kind of a lock and twist metal that's on.
You can't get any
it's really
better
nice.
than this in terms of the lens quality and all that. But anyway, opened up this Fusion file, edited the little counterweight here, like I said, modified the sketch to fit the Osmo Mobile 1, and then added the thread inside of Fusion 360. It just worked with this little cap that's just holding it on there. It just goes on like that.
Nice.
And still had the zip tie on there, but because I did design the tolerance really tight on there, you don't even need it. So
okay, cool.
Snaps on like that.
Locks in.
And does a really good job of stabilizing this super heavy lens. So yeah.
Let's go to the
for any of people
F-cam.
who are interested in any of the behind the scenes production video stuff.
Right. No, I mean
this is how we were filming.
The iOS devices, they have built-in image stabilization, but this just adds a whole other layer of it.
Go back and watch the video. I'm doing a ton of running around
and
trying to catch. Have you ever tried to film a 5-year-old running around?
Oh gosh, no.
You
ever tried a lightsaber, 5-year-old? Come on.
Yeah, so definitely recommended for steady hand stabilized shots for any maker projects.
They might be on sale because this is version 1. They have a version 2 that's like thinner or something.
Yeah, I looked at the reviews. This is still more expensive.
Really?
Yeah.
Oh, okay.
There's like caveats and whatever. Like each one does something different. But in the end, I figured we already got this.
How much is this Osmo? Is it like
$300?
300?
Yeah.
Okay.
You could probably find it cheaper.
A used one, maybe.
Yeah.
Cool. All right. Well, that's just a quick look at some practical.
If you do have a tube, check out his Thingiverse link there.
Yeah, practical 3D printing, video production, making camera stuff. We love making camera stuff with 3D printing.
Yeah,
so it's always the best.
Yeah,
great use of it.
Let me go back through some of the comments here. Could be saying, yeah, the 2 is plastic and cheaper. Yeah, it's only $139.
What? It's like cheaper and worse. What is up with that?
I mean, it's just a
version 2, worse and
but it has
more expensive.
No, this one has a removable button. It's like pros and cons, and yeah, once you take a look at it, I was like, I already got this.
Anyway, win for 3D printing. You can make your own. You can adapt your stuff to work with other things. Exactly. That's great. Excellent.
If you are interested in more video production, 3D printing projects, we have a ton.
On the Learn Guide.
We got video.
Should I type something in camera? Just type in camera and here you go.
Stuff, tripods,
sliders, monitors, this
lights,
cool BMO face, tripods,
like time lapse,
barn doors for your camera, a camera battery adapter, a lot of cool little camera things. 7 pages worth. All right, well that is really cool shop talk. And again, shout out to the person on Thingiverse for open sourcing their design. Source for the win.
We'll be posting this as a remix, Fusion 360 file there. So
my face just went, because it's already 12.
I know, I just don't get
time, man. I guess we're going overtime. All right, if you guys are still with us, thank you so much. FeatherWing is the coupon code. We're going to run through some quick things. The Adafruit jobs board is up, so you can check that out if you are looking to hire some makers, or you're looking to expand your skills and you want to get paid for it. You got the skills to pay the bills. Adafruit has a jobs board, so go to jobs.adafruit.com.
These awesome jobs.
These are awesome jobs. Little Bits just posted. Hackaday, they're looking for a hardware marketing advocate. That sounds so much fun.
It's almost like our job.
An industrial engineer for DigiKey, embedded firmware engineer for Bantam Tools. These are fun maker companies. They're friends with Adafruit, and it's really cool. So if you want to post your maker profile, please do so. You can do so, sign up for free. So you got this, search jobs, or you have this available for hire. This thing has been being worked on for quite a bit now, so please test it out and post up your stuff.
Tested, yeah, in terms of security flaws.
Look at all these awesome makers. We got some from all over the place.
Ooh,
Orlando, Florida, New York, Brooklyn, Portland, Oregon, all these places. So check them out.
And if you're a frequent show and teller, we might even give you guys recommendation.
That's right. Wow, very cool. All right, so that's the Adafruit jobs board. Let's go and move into Community Makes this week. We have a time lapse that we 3D printed from the community. This one is a really nice, fun one. If I can pull up so this is a flexible skeleton. Printing things with joints, print and play stuff is always fun. And we scaled this one up really, really huge. This one is from Thingiverse user Zad Mariation. And they made this really cool, just in time for Halloween, a flexible skeleton that's flossing right now.
A lot of
print and place joints are always fun to print.
Halloween printing projects this year.
Yeah.
It's shame that we can't get to all of them.
Yeah.
That's actually why we
I wanted to print Liz's pumpkin so bad, but it's like, oh man, I ran out of time. So anyway, this is the post on Thingiverse. Ben's skeleton. So it's just a print and place joint.
In May, so he was thinking far ahead.
Yeah, totally. I don't even know if he printed it. It looks like a render.
Oh yeah, you're right.
Cool. Well, this is it 3D
best
printed.
Use of the hinge joint stuff that everybody's been doing because of the ribs.
Yeah, we hinged a dog. We had a hinged fish. We had a hinged everything.
How modern is because it can do the floss.
And he's flossing. Yeah, and this is printed in Filamentum's Mint.
Oh yeah.
So much Filamentum. Yeah, so it's printed on the Ultimaker, just a single extrusion. The tolerances are good, so it's assembled right out of the printer.
Now you can kind of see the hinges there. Because it's so big, doesn't matter.
Yeah, it's so perfect to see his little skeleton pieces here.
So move there.
He sounds like a skeleton.
The clacking.
Clacky clack. So cool.
This will definitely join all of the 3D printed decorations outside.
It only takes a day to print. Does it take a day to print?
I scaled this up as big as it could, so it's like 300 something wide.
Yeah. This is like an infant, like the size of an infant baby.
Yeah.
Anyway, very cute and very, very, very nice use of print and place joints. Excellent.
Put a Halloween on the head.
Oh, that would be great. Yeah, third eye. That'd be excellent. Yeah.
What?
All right, we'll do that next year. We'll have to remix it. Well, shout out to you, sir, for Thingiverse. We got some other makes, so we're going to run through them pretty quick. See if we can do this. All right, let's see. Oh, last minute. If you want the prop maker FeatherWing, the M4 Express, the RGB buttons, or any of those parts 3D modeled as a step file, you can download them from our GitHub. I have it linked in the description of this video. I also have it linked here. Just go to GitHub and search for Adafruit CAD parts, and you can find all the parts that we use, that we model, that are exported out of Eagle and painstakingly modeled. Sweet. This is a really nice one. This is a, we're seeing a lot of great projects using the Halloween PCB, but this is one of the most heartwarming ones. A group of makers came together and they tricked out a 10-year-old's wheelchair with the Halloween as a dragon.
This is the most awesome project.
It's very cool. Check out the YouTube video on it and our blog post about it. And everybody else who shared it, thank you so much for doing that. It's so awesome. We got another one. This might quite possibly be the most, it's a set of 5. There's 10 here. There's 10 Halloween eyes. Shout out to Wormy for putting this project together. He shouted me out on the 3D printed snap fit cases as he implemented that kind of style into these, and there's just so many of them. Does phenomenal videos, does really, really great work. Check him out on Thingiverse and Instagram. He shares all his work. Very, very awesome. Shout out to Wormy. Shout out to Ali for creating quite possibly one of the best linear servo actuators. Everybody's been downloading this. He shared his Thingiverse stats, and they're just like crazy, because this is the most useful actuator. And it's just a couple pieces here that fits your off-the-shelf continuous servo. So we're going to be putting this to use as well. So huge shout out to Ali for sharing this. And we got some makes. Shout out to this folks here. We got the IoT Gmail box. This person here posted a make of it. It works really well. It uses a little servo, a battery, and one of the ESP8266 feathers to tie into Adafruit IO and if this then that. So whenever you get an email, you get a little flag. Very fun. This This is one of the iconic cases that we made back in the day. This is a Domo-kun-inspired face case. We got a face case for your Pi face. This is a really cool Halloween add-on. This is a skull face for adding on top of a Halloween thing. Very, very cool.
I like if that's filament or the post-processing work.
I think it's like paint or something.
Really
Person
cool.
here talks about it.
Very cool.
Very cool. All right, and then we have a case. I thought it was a laser cut case. It is a laser cut case, but it's kind of hard to see. There's this 3D printed stand. So there's the stand. Yeah, we made a stand. So if you want a stand for your Pi screen, there you go. This is great. I've been seeing a lot of this one. This is the Mario Boo. So you can use this as a candy bowl or a planter all year round. Paint it, and there you go. Looks real nice with the succulent in it. There's the Ben skeleton. There's the prop maker. And this is we made a Link's shield a couple of years ago. And this gentleman here printed it for his cat.
Seems to be on
his cat.
Is it Cats of Cosplay?
Cats of Cosplay. Yep. 3D printed small. Nice painting. And cat. Kitty Link. Sweet. Well, that's all the things I got. 7-minute server, not too bad. There's more show later tonight. We have Ask an Engineer. So if you don't want to go trick-or-treating and you want to share your costume and stuff, go on the Adafruit Show and Tell at 7:30 p.m. You can win a sticker. All the contestants get a free sticker. And you get to talk to Lamar and Phil. Shortly after, at 8 p.m. Eastern Time tonight. We're doing the shows, right?
Yes.
I think they're doing the
We're gonna
shows.
do it from outside while we're trick-or-treating.
Okay, cool. Awesome. We'll be doing some sabering. Yeah, so Ask Engineer is on every Wednesday at 8 p.m. You get to see Lamar and Phil, full hour of Lamar and Phil, new products, and more. What is that? Is that another minion thing? That's awesome.
Yeah.
Is that Mike?
That's hilarious.
That's Mike B, yeah.
It's down.
Oh, yeah, sorry.
Don't forget tomorrow.
Tomorrow, John Park.
Yes.
Be sure to tune in tomorrow, John Park. And you get some maker minutes and some live builds. So be sure to tune in
Super
every
awesome.
Thursday,
It's
4
getting
p.m.
ramped up the next ADA box, so definitely tune
It's
in.
a big
if you want
one.
Some sneak peeks of that.
It's a big one.
Yes.
And thank you so much for supporting this little company called Adafruit.
All of the orders, all goes to everybody who works there.
Yeah.
And people.
That's
to
right.
work on all
The only way this
these
can work
Yep.
is if you keep supporting us.
To work on all these crazy.
Not
cool
with YouTube views,
projects.
but with actual orders. So we thank you very, very much. Oh man, so many things. Well, we've reached the end of the show, and all that's left to do is play a fail video or something. Well, thank you guys so much. Have a safe and festivist for the rest of us. Good luck with everyone's maker endeavors, and don't forget to just make a great day.
See you guys next week.
Bye. Here's the print. Failed. This is the blade emitter.
So what happened here was over extrusion.
My settings were wrong. I had this extra retraction settings for PVA because PVA tends to under extrude, and I forgot to change it, so it's just pumping out extra plastic that it doesn't need to. And if you see that shakiness, it's because the printer's like just like plopping right into it. And it's not knocking it off yet. It does eventually, but I canceled it. And this is one of the older designs. It's much thicker now because that broke right away. So that's it. Why am I still... All right, bye everybody. We'll see you tonight.
See you guys.